I just wanted to do a quick talk over double replacement reactions and complete and net ionic equations. So first of all, hopefully remember, a double replacement reaction is essentially just where you switch partners. So to find the products, I have a sample reaction here. To find the products, you just switch what is in front. So what we're going to end up with is sodium paired with nitrate. We know we can do it 1 to 1 because sodium's +1, nitrate's -1. Silver is +1 and chloride is -1, so the other product is silver chloride. Now, to know if this is actually a reaction, we have to find out if we made a precipitate. A precipitate is a substance that is insoluble. So, first of all, if you look through your solubility rules at all of these, one of the rules is that all nitrates are soluble. And so that means that this one and this one are both soluble. Now, in a double replacement reaction, in this class, you're not going to have to worry about any of the reactants being insoluble. They will always be soluble. But for the sake of using our solubility rules, you can look down and you can see that all nitrates are soluble. For the other two, you have to look at chlorides. And it says all chlorides are soluble unless it's paired with silver, lead, or mercury. So this one is soluble, so we put the AQ, but on this one we put an S for solid. So we did indeed make a precipitate, and this is the precipitate. So the complete ionic equation is where we actually kind of show what's happening in the beakers if we're mixing these together. So what ions are floating around? Well, if you remember our little talk, when you dissolve something, what's happening is the substance is splitting into its ions. And so if we were to kind of draw a representation of what this reaction actually looks like, everything that can split apart should be split apart. So this is aqueous, so it can be split apart into silver plus, we keep the little AQ sign, and nitrate is an anion. The sodium chloride can be split apart also, so sodium plus and chloride minus. Well, chloride is minus. Then, on the other side of the equation, you have sodium and nitrate. And then your silver chloride, which stays together because it's the precipitate. And that's an S, I'm sorry. It really doesn't look like one. So that's your complete ionic equation. Everything that can be split apart is split apart. If you had to balance the original equation up here, you'd have to make sure to carry your coefficients down with it, or if it's something like calcium chloride, you'd have 2 chlorines attached to the calcium, so instead of just 1 chlorine here, you would have had to put 2 in front because it's going to totally split apart. So that kind of shows you exactly what would be happening in the beaker if you mixed a solution of silver nitrate and sodium chloride. You have all those ions, and then the silver and the chloride are going to eventually collide, and they're just going to stick together and form a solid, the precipitate. Notice that the sodium and the nitrate, they appear the same on both sides of the reaction. It's sodium plus and nitrate with a minus charge. On both sides, they don't change, so they're not even involved in the reaction. So they are what we call spectator ions. Spectator ions. We call them spectator ions because they're just watching. They're not actually involved in the reaction. So this brings us to the net ionic equation. And the net ionic equation is the one where we get rid of spectator ions and only include what it actually is involved in the reaction. So in this case, what's actually reacting? Well, Ag plus is reacting with the chloride ions, and they are making silver chloride. And then that's all you would do. So this would be the net ionic equation. This up here, complete ionic. And then this would just be the chemical equation. So I hope that helps. You just follow these steps for questions that ask for one or both of them. If you're asked to find the precipitate, all you have to do is this top part and figure out if it actually does make a precipitate. If it does not make a precipitate, if it doesn't make something that you'd put S by, then there's no reaction.